In today's lesson, we are going to be looking at solving systems by substitution. So this is a continuation of our linear systems unit. And previously we've looked at how to solve a linear system by graphing. Now that's easy, or that's nice depending on what type of equation we're given. Maybe we're already given the graphs and we just want to find the solution, or maybe the equations are in y equals mx plus b form, which makes it easy to graph. But sometimes they might not be in that specific form. Maybe they're in standard form and we'd have to rearrange and then graph. Or maybe when we graph it, it doesn't cross nicely on a grid line, so we can't accurately get the correct solution or the correct point of interception. So what we might have to do, or intersection, what we might have to do is solve by substitution. So this is going to be a way where we can still find that point of intersection without having to graph. So it's going to be a little bit more mathematical. It's going to require an understanding of rearranging equations and solving equations. But we're going to go through some step-by-step examples, look at some word problems for it, and then hopefully you get more comfortable and have this option as a way to solve a linear system. So the steps to solving a linear system by substitution. First things we want to do is we want to choose one equation and rearrange it for one of the variables. Right? So the variables we're going to be dealing with are x and y. Right? So those are the two variables that we're going to be dealing with in our equations, x and y for the most part, and we want to choose to rearrange for one of those variables. When you're rearranging, you want to try to avoid fractions. And so what we mean by that is basically the variable you're trying to rearrange for probably shouldn't have a value in front of it. It should just be the variable on its own. And again, we'll look at an example, or when we walk through the examples, I'll point that out. Once you rearrange an equation, you're going to substitute the rearranged equation back into the other equation. So you have two equations, you're going to rearrange one and substitute it into another. Once you do that, you're going to solve for the remaining variable to get an answer, and then you're going to substitute that value back into one of the original equations and solve. And at the very end, you're going to check your answer and state the solution. Now, this checking your answer part, sometimes the questions may not ask you to do it, but it's a good way to always check to see, did I get the right answer? So we're going to start off with this linear system. So we want to solve using substitution, and looking at these two equations, they're not in standard form, they're not in y equals mx plus b form. They are in standard form, and I don't know if I'm going to get the right or get a nice answer. So I'm going to, I'm just kind of changing the size of the pens here. I'm going to solve by substitution to avoid having to graph and just to make sure that I can get the most accurate answer. So first things first, I'm going to label each equation as 1 and 2. Now this is just going to help me just kind of know which ones I'm dealing with. You don't really have to do it, but it is a nice way to help organize some of your thinking. So first step, we want to rearrange, and these colors are going to match the colors of the steps on the previous page. So we want to rearrange one of the equations. And remember, we said the goal was to avoid fractions. So if I'm looking at these two equations, there is one that stands out that's going to be easier to rearrange. And that is going to be the first equation. So I'm going to rearrange equation 1 and say to isolate x. So if I look at equation 1, this x variable is by itself in the sense there's no number attached to it, it's just x. So I can easily rearrange for that variable. Now, in some cases, maybe you rearrange for y. Maybe you rearrange for x and others. It just depends on what you see or what equations are given to you. So it might change, but again, we'll look at some examples of the other way as well. So I want to rearrange this equation for x. So if I have x minus 2y equals 4, I want to isolate x, so I'm going to move the 2y over, or the negative 2y over. So it becomes x equals 4. The negative 2y becomes positive 2y. And now I've rearranged my equation. So I've rearranged my equation to isolate for one of the variables. The next step is we are going to substitute. So we're going to substitute it into equation 2. We'll say we're going to substitute x equals 4 plus 2y into equation 2. So what that means is if I take equation 2, 2x minus 3y equals 7, I'm going to substitute or replace the x with 4 plus 2y. So 2 times 4 plus 2y minus 3y equals 7. So now I've substituted one equation into the other and removed one of the variables. So when I look at this equation now, there's only one variable there, the y value, or the y variable. So what I can do with that is I can go through, and actually I'm going to have to change this up a bit because I'm going to not have enough room. Just bear with me for 1 second, just changing up the sizing. So I'm going to substitute into equation 2, which I did. The next step, what we're going to do next, is we want to then solve. So I want to solve this equation for the missing, or solve for y. That's the only variable left. So first things first, I want to expand. I want to multiply that 2 through the bracket. So I'm going to just start. So 2 times 4 plus 2y minus 3y equals 7. 2 multiplies by through, so I get 8 plus 4y minus 3y equals 7. I can collect like terms. 8 and then 4y minus 3y is just plus 1y, or plus y equals 7. Move the 8 to the other side. It becomes minus 8, so I get y equals 7 minus 8, or y equals negative 1. So now I have a y value, and this is going to be the y value for the point of intersection. Right? So this y value, I found part of my coordinates. I need to find the other value, or the x value. So what we're going to do next is now we're going to plug y equals negative 1 back into the first equation that we use. So back into equation 1. So if I have x minus 2y equals 4, I'm going to replace the x, or the y, with negative 1. So x minus 2 times negative 1 equals 4. And now I'm going to solve. X plus 2 equals 4. Move the plus 2 over. I get x equals 4 minus 2. X equals 2 as our final answer. Now, we plugged it into equation 1. Technically, we could plug it into equation 2 as well and still get the same answer, because the point of intersection is going to be the same for both equations. All right, that point is going to exist on both parts. So, therefore, the POI is x value first, 2, negative 1. Now what we can do as well, we can go through and check, right? If we wanted to, we can check. So let me go through and just kind of rearrange or reorganize a little bit of this just to have enough space. So I rearranged, substituted the value into the equation into the other equation, solved for one variable, took that answer, plugged it into one of the equations to solve for the other variable. found our point of intersection. Now we're going to check our answer. And we're going to check by plugging it back into both equations. So if I look at equation 1, it was x minus 2y equals 4. So if I plug in the point 2, -1 in for x and y, so 2 minus 2 times -1 equals 4, I should get that this works out. 2 times -2 times or 2 minus 2 times -1, we get 2 plus 2 equals 4, and we get 4 equals 4, which does work. So that is, that works for that equation, but we also have to check it for the second one. So the second equation, 2x minus 3y equals 7. I'm going to plug in my values. So 2 times 2 minus 3 times -1 equals 7. I'm going to simplify. 4 plus 3 equals 7. 7 equals 7, which is true. So it does work. That is our correct answer. And that is those are the steps to solving by substitution. So we went through, we found the point of intersection without having to graph. Let's go through and do the second one, a little bit different, right? So we're going to solve, right, for substitution, or using substitution, and we're going to check our answer. So I'm going to label, so equation 1, equation 2. Looking at these two equations, which one do you think we would want to rearrange? Remember, we don't want fractions, so we want to look for a variable that's on its own with no value or term in front, or no value in front of it. In this case, it would be the y in the second equation. So I'm going to rearrange equation 2 to isolate y. So I'm going to get y by itself. So 2x plus y equals 6. I want to get y by itself, so I'm going to move the 2x over. So I get y equals 6 minus 2x. Goes from plus 2x to minus 2x. And now I have a rearranged equation. What we're going to do with that equation now, we're going to substitute it back into the other equation, the one we didn't use. So if we rearranged equation 2, we're going to substitute that rearranged equation into equation 1. So sub y equals 6 minus 2x into equation 1. So we have 3x plus 2y equals 4. And instead of y now, I'm going to replace it with 6 minus 2x. 3x plus 2 times 6 minus 2x equals 4. And now I've substituted it in. Once I've substituted it in, now I can solve for the missing variable, or x. So I can solve for x now. So 3x plus 2 times 6 minus 2x equals 4. I'm going to go through and solve. So I'm going to expand first. So 2 times 6, 2 times -2x. We get plus 12 minus 4x equals 4. Collect like terms. I can collect my x terms. 3 minus 4 is -1x. Plus 12 equals 4. And now I'm solving this two-step equation. I'm going to move the 12 over to the other side. So I get -1x equals 4 minus 12. -1x equals -8. Divide both sides by -1. I get x is equal to 8. So there is one value. So I found part of my point of intersection. I need to find the other one. So I'm going to sub x equals 8 into, And again, it doesn't really matter which one we sub it into. It should give us the same answer, but we want to sub it into the one that only has fewer constants or fewer values in front of the variable. So I'm going to plug this back into equation 2, just because it's going to make it a little bit easier in the long run when I have to solve for y. So take equation 2, which is 2x plus y equals 6. Instead of x, we're going to write 8. So 2 times 8 plus y equals 6. I get 16 plus y equals 6. I'm going to move the 16 over. So y equals 6 minus 16, or y equals negative 10. Now that I have my x and my y coordinates or values, I can say that therefore the point of intersection is 8, negative 10. If we wanted to, we could again plug these values back into our two different equations. Let's do this quickly. So check. So we're going to have 8 and negative 10. So I'm going to take each equation. So the first one, 3x plus 2y equals 4. Replace the x and y with the values from the point of intersection. So 3 times 8 plus 2 times negative 10 equals 4. Get 24 minus 20 equals 4, and 4 equals 4, which is what it simplifies to, which is correct. 4 does equal 4. So that point of intersection is on the first line. Now we do need to double check to make sure it's on the second line as well. So the 2x plus y equals 6. So 2x plus y equals 6. I'm going to plug in those 2 points, or those 2 values, sorry. 2 times 8 plus negative 10 equals 6. 2 times 8 is 16, plus a negative is minus, so minus 10 equals 6. 16 minus 10 is 6. So 6 does equal 6, which is correct. So that means that that point or that answer is correct. Again, the checking, you might not always have to do it, but it is a helpful way to check your answer if you don't have the answer in the back of the book, or if you're doing an assignment or a test or a quiz and you want to know if you got the answer right, you have a way to check. Right, so now let's move into some word problems. So Maria and Nancy played in a volleyball marathon for charity. They played for 38 hours and received $412. Maria was sponsored for $10 per hour and Nancy was sponsored for $12 per hour. How many hours did each play? So what we have to do here is we have to come up with our equations first. But before we come up with our equations, we need to figure out, okay, what are our variables? Right? What are our unknown values? What are our x and y values? So what we're going to do first is we're going to say let, and we can pick a variable. So we can pick a letter if we want, or if it's helpful, we can leave it as x and y, whatever you prefer. But let's change it up a bit. Let's say let m, because if we look at the question, how many hours did each play? So our variables should represent the hours for Maria and Nancy. So we're going to let m equal the number of hours for Maria. And we're going to let n equal the number of hours for Nancy. Now the tricky part here with the word problems is we need to come up with 2 equations now. So equation 1 and equation 2. So we have to look back at the scenario because there are 2 different things that it's giving us. And one is it's giving us how much they played and how much money they made, or how much money they raised. So those are the 2 things that we're going to come up with for our equations. So there is an easy one, the hours for Maria, m, plus the hours for Nancy, N, have to equal 38. The other equation is going to have to relate to the $412 that they earned or that they made. So how would we calculate how much money they made using these two variables? Well, we know Maria was sponsored for $10 per hour. So however many hours she played, M, if we multiply that by 10, that would be how much money she made. Same idea for Nancy. She was sponsored for $12 an hour. So if we know how many hours she played, then we can multiply that by 12, and that would be the money that Nancy made. And then adding those two together would give us the $412. So now we have our two equations, one representing the hours played and one representing the money raised. So now that we have our two equations, now we can go through and solve using solve by substitution, very similar to what we did in our last two examples. So the first thing we're going to do is we are going to rearrange. So we have our equations. First, we're going to rearrange one of them. In this case, we're going to choose to rearrange equation 1. And again, the reason we're doing that is because if we look at the variables m and n, there's no values in front of them in that first equation. Now, because there's no values in front of either m or n, we can choose whichever one we want, right? So you can solve for m or rearrange for m or rearrange for n. It's up to you. So we're going to rearrange to isolate. Let's say we're going to isolate m. We want to rearrange and find m. So if I have m plus n equals 38, I want to get m by itself, so the n is going to go to the other side. M equals 38 minus n. Straightforward rearranging for that one, not too difficult, I hope. We've rearranged it. Now we have to substitute. So now we're going to substitute what we just rearranged, so 38 minus m equals 38 minus n, into the other equation, equation 2. So we have 10m plus 12n equals 412, but instead of m, we can replace that with 38 minus n plus 112 is going to n is going to stay the same, equals 412. Now that we've substituted in, what we have to do now is we have to solve. So we have to solve for our only unknown variable, which is n. So if I have 10 times 38 minus n plus 12n equals 412. First, we're going to distribute our property, multiply the 10 through, 380 minus 10n plus the 12n equals 412. Collect like terms. Minus 10n plus 12n is plus 2n equals 412. I want to get n by itself, so I'm going to need to solve this two-step equation. The 380 needs to go to the other side. 2n equals 412 minus 380. 2n equals 32. To get n by itself, we're going to divide both sides by 2. One side is going to cancel out. And we have n is equal to 16. So we know part of our point of intersection, or one of our variables. We need to now find our other variable. So we are going to substitute n equals 16 into, and if we look at the two equations, right, the easiest one to solve for would be equation 1. Either you could plug it into either one, you should still get the same answer, but if we look at the two equations, equation 1 is really easy to work with, because if I know Nancy works or played 16 hours, and in total they played 38 hours, that's an easy equation to solve. I could almost do that in my head. m equals 22. So we're using these two equations not necessarily to find a point of intersection, but to help us, like, while it is a point of intersection, if we were to graph it, it's not when the values are the same, but it is when we can use it to determine how many hours they both played. So therefore, Nancy played 16 hours and Maria played 22 hours. So that would be using the method of solving a linear system by substitution to help us answer this question. One more example, very similar to the other one that we just did. It's a word problem, so we're going to go through and solve in a similar way. So what we're going to do, or let's read the question first. So Sarah is setting up a business in which she will hem pants. Her startup cost to buy a sewing machine is $1,045. She will use about 50 cents in materials for each pair of pants. She plans to charge $10 for each pair of pants she hems. How many pairs of pants does she need to hem to break even? So first things first, we need to figure out how many pairs of pants does she need to hem to break even. So what does break even mean? Well, if we're going to break even is when the cost of running something or the cost of something is equal to the revenue or how much you're making. Right? So if your cost equals your revenue, you've broken even. You're not making money, but you're not losing money. Right? So let's use that to help us come up with two equations. Now there's only one unknown here. How many pairs of pants? So our unknown is P. So we're going to let P equal the number of pants. So only one variable that we're dealing with, but we're going to use the idea of substitution to help us find our unknown value. So now let's come up with our two equations, equation 1 and equation 2. We know we can set them equal to each other. Or we have our two parts that we're going to look for, the cost and the revenue. So let's look at the cost first. What is our cost? Well, the money that she's going to be using, we have 50 cents per pair of pants, so 0.5 times P, plus the 1,045 for the sewing machine. So those are all of her costs. Her revenue is going to equal $10 times the number of pants that she hems. So that's her revenue. That's how much money she's going to make. Now this one's a little bit different. We don't really have to rearrange here because they're both going to go into the same equation and there's only one variable. So we don't have to rearrange here. So we're kind of skipping a step and we don't have to substitute one into the other, but we can say if we want, equation 1 has to equal equation 2, right? Your cost has to equal your revenue. So when we plug those values in, we should get 0.5p plus 1,045 should equal 10 times p, and that would be when we break even. We can go through and solve that now. So we can solve for P. So 0.5P plus 1,045 equals 10P. I want to get all my variables on one side. I'm going to move the 0.5P to the other side. 1,045 stays the same. That 0.5P goes from a plus to a minus on the other side. We get 1,045 equals 9.5p. I want to get p by itself, so I'm going to divide both sides by 9.5. One side is going to cancel out. And we are left with 110 equals P. So in kind of a modified solving by substitution, we still you could argue we're still graphing essentially two lines, and we are finding a point of intersection. You could argue if we were to graph it, this is where it's meeting. So here we have, therefore, she needs to hem 110 pants, or pairs of pants. So this last one was a little bit of a different style of solving by substitution, just because we're talking about break even. So we're not necessarily plugging one into the other. We're setting both equations are kind of in the same equation, in one equation itself, or both parts are in one equation. This other one with the volleyball one, this is more typical of two lines being graphed, two different equations. So different scenarios that you might come across when looking at word problems. But we do have then the basic examples of here's two equations, find the solution or solve them by finding the point of intersection using substitution. But the main thing is, again, going through, making sure you're comfortable with these steps. And again, sometimes it might just take practice to get comfortable with them, so you remember the steps. So again, just make sure you are practicing, referring back to these steps, referring back to the examples in this note.